Hello, my name is Anthony Alvarez for Dr. Shea's MIS 665 class. This is my loan cancellation final project that is due on the 4th. You might hear clicking throughout this. That's just my mouse because it is close to my mic, so sorry about that. So my final project has to do with, um, like everyone else's, loan cancellations. The steps that I took are the first one being data import and understanding. The second one is data cleaning and preparation. The third one is business intelligence and statistical inference. The fourth is classification. The fifth is regression. The sixth is clustering. Seventh is hypothesis. Eighth is managerial implications. And then ninth is the technical implications and suggestions. Mine focuses a lot on risk score and how that actual how the inability to use a lot of that data because of it being so low, or so, or not being answered often, and how that comes back to bite them, and that will play into the effect at the end for the managerial and the technical implications. So here we have the data import. We're just gonna fly through this first section so we can talk about the models. This is the data understanding. You'll see this in the Jupyter notebook. Um, all of the info and columns here, the basic statistics, the mean of 9% for the canceled rate, and then everything you need for these. The very bottom here, I will show you the risk score. I do focus on that a lot later. That C right there, the almost 12,000, that will come into effect later. I ran a correlation a little early in this because I wanted to know which columns are pretty much useless. Like the borrow category obviously has nothing, but all these agent cancel forms, e forms, everything, they're not correlated to canceled. So I decided to pretty much toss them right away. Like I said, there's all the 140,000 plus entries. Average term is 9.5 months, so they're all pretty short loans. Um, APR average 12%, which is pretty average. But yeah, so I will go ahead and jump onto data cleaning and preparation. So a new plan of action for this is remove all of the variables that aren't correlated, replace the ones that need to be replaced. So that borrower credit score with that NS, I made it 2 because that's the most common. I drop the leftover null values, and then I convert the dates that need to be converted. Row removal, like I said, gets rid of it, and that brings us down to 27 columns. Replace values, and then converting columns. And then once that's all done, I go ahead and you have all of the dates and date time and all of the credit scores and everything that needs to be correct is correct. It takes us down to 16,892 unique entries. That's quite a bit lower, but in the end, you can still make pretty solid models off of it, so I'm not concerned about that drop. Business intelligence and statistical inference. So this plan of action here, it's less of a plan of action, more of what I'm going to look for. The hypotheses that I went after are the accepted monthly loans are higher in the summer. Cancellations will be drastically bottom heavy for risk score, just because of that C at 11, almost 12,000 entries. And then hypothesis, the last one is cancellations will be worse in southern states. I did another correlation just with the clean data to make sure that everything looks good. So monthly accepted loans, they are higher in the summer. June, August, July are the highest, and May is not quite summer, but it's also the fifth highest. And then these are the cancellations were actually pretty high in the summer. And then you can see a little bit of seasonality here. Loans cancellations by category and subterm. So services in general are the highest, general, other, and general services are the next highest for the subterms. Monthly cancellations. You can see that spike in January for cancellations. I jump into that in the notebook. Cancellations by risk score. So cancellations by risk score, C had 5,600. That's over half of their um, excuse me, over half of their accepted loans. So in the end, they should really be going after B's and A's because that is a huge difference of like 20%. And then you can see the risk score canceled. Cancellations by category and subterm. Services in general, obviously they were the highest, and then general and services, general other and general services were the highest for subterms. Cancellations by state. So I thought most would be in the South, just because their summers are longer and they seem to have a lot higher entries from there. So Texas, Louisiana, Mississippi, Florida, Oklahoma. Enough said. That's a correct hypothesis. Diving into 2018, the cancellations 2018 were skyrocketed. You'll see more of that in the notebook itself. Statistical inference. Um, the premium data is not normal, so the p-val, I ran the Games Howl and the Welch, and this is a 0.01 p-value, so we accept the null hypothesis. There's extra data visuals in the notebook just to see other parts or other ways of looking at the data. And then there are more findings here that I mentioned before. Classification. So another plan of action really just comes down to validating with the ROC or AUC plot. I used decision tree, k-neighbors, and random forest. I ran another correlation just to see. We have those almost 17,000 there. So the decision tree classifier is at 92% accuracy with a 95% recall rate, which is pretty solid. And you can see this AUC graph here to validate it is pretty good. The K neighbors is at 86 and 98, which is quite a drop off for accuracy. And you can see that the AUC is not great at 53%. The random forest classifier is 92 and 98, so it looks like it's the best. And you can clearly see that in the graph here with the AUC of 94%. And then I ran a feature importance just to see what was the most important. Payments received, late charge, and finance charge are all up there. So regression, another plan of action. I obviously go with premium, like it was said. The first regression had a 2.2 mean squared error, but a 96% R square. I ran a feature importance, got a 6.3 mean squared, 98% R square. Found the finance charge and down payment are very important. Then I ran a stats model with OLS, then 94% R square, and then a 3.3 MSE. I used regularization here and it did not work out. But the feature selection I jumped into, used 4 and 5, which are down in finance charge, and got a 94% R squared and a 3.5 MSE. And I went with the feature importance with the top 4 because that's just, honestly, it's easiest to use. Clustering. So clustering has all this. I found 4. K4 was perfect for the K. And I went with agglomerative clustering. So storytelling, my hypotheses were all correct. The cancellations was off because of the 2 to 3 range, but it was still mostly correct. My managerial implications, you'll see this in the notebook. They should go after better loans in Texas and in the South. That's my thought. Risk scores, they should actually create an initiative to have risk scores enter because there were over 100,000 non-entries, and that benchmark should hit at least 60%. Then I have more suggestions at the end. Thanks for listening. Bye.